Imagine a world powered by the sun, not just for homes, but for entire continents. This vision is becoming reality, a project connecting Africa and Europe with clean energy from the Sahara. Solar power becomes hydrogen, traveling by pipeline to fuel European cities. A bridge between continents and a future powered by renewable energy. So what is this miraculous fuel that could power our future? It's called green hydrogen, and it's the simplest, most abundant element in the universe. Hydrogen is the stuff of stars, the fuel that powers our own sun. On Earth, it's almost always locked up with other elements, most famously with oxygen to form water, H2O. The promise of hydrogen as a fuel is that when you burn it, the only byproduct is water vapor. No carbon dioxide, no greenhouse gases, no pollution. It's the ultimate clean fuel. But for a long time, the challenge was how to produce it cleanly and efficiently. This is where the green in green hydrogen comes in. The color tells you how it was made. For decades, most hydrogen has been produced from natural gas, a process that releases a lot of carbon dioxide. We call this gray hydrogen. But green hydrogen is different. It is produced through a process called electrolysis, which is a fancy word for splitting water molecules. Imagine using electricity to zap water, breaking the bonds that hold the hydrogen and oxygen atoms together. The result is pure hydrogen gas and pure oxygen gas. It's like running the chemistry of combustion in reverse. The key to making this process green is the source of the electricity. If you power your electrolysis with electricity generated from renewable sources, like solar panels or wind turbines, then the entire process is carbon-free. You use sunlight or wind to make electricity, you use that electricity to split water, and you get clean hydrogen fuel. The Sahara Desert, with its endless sunshine and vast open spaces, is the perfect place to build the massive solar and wind farms needed for this process. It's a perfect synergy of geography and technology, turning sunlight and water into a transportable, storable, and completely clean form of energy. This makes green hydrogen a game-changer in our fight against climate change. It's not just for generating electricity. It can replace fossil fuels in industries that are difficult to decarbonize, like steel and cement production. It can power heavy-duty trucks, ships, and even airplanes. It can be stored for long periods and transported over long distances, just like natural gas is today. This pipeline from the Sahara isn't just about sending electricity to Europe. It's about sending a versatile, powerful, and clean molecule that can transform our entire energy system from the ground up, heralding a new age of sustainable power. At the heart of this vision is hydrogen, the universe's most common element forged in the Big Bang. It fuels the stars, and on Earth it's everywhere, locked in water, clouds, and every living cell. When combined with oxygen, hydrogen powers rockets and produces only water, no pollution. Now, we're learning to unlock hydrogen cleanly, using the sun's energy to power our world sustainably. Electrolysis uses electricity to split water into hydrogen and oxygen, a process that's clean, quiet, and almost magical. If powered by renewables, it creates green hydrogen, a clean fuel from start to finish. Solar farms capture sunlight, powering electrolyzers that make hydrogen, which can be stored and transported. This lets us use clean energy day and night, making green hydrogen a true game changer. Not all hydrogen is created equal. The industry uses a color code to show how hydrogen is made and its environmental impact. Gray, blue, and brown hydrogen rely on fossil fuels and produce emissions. Green hydrogen stands apart. Made with only water and renewable electricity, it's the cleanest choice for our future. The Sahara Desert is the largest hot desert in the world, an ocean of sand and sunlight. Its relentless sun makes it the perfect place for massive solar farms, generating clean electricity. Covering just a fraction with solar panels could power the entire world. Here, geography and technology unite to create the cleanest fuel on Earth, reshaping our energy future. The Sahara's sun is just the beginning. Its vast, empty land is perfect for massive solar and wind farms, something crowded regions like Europe can't offer. Here, sun and wind work together, powering hydrogen production day and night. And with Europe just across the Mediterranean, the Sahara is poised to become its green energy powerhouse. For centuries, the Sahara was seen as a barrier, vast, inhospitable, dividing Africa. But now, technology is transforming it into a bridge. Solar panels and pipelines turn relentless sunshine into green hydrogen, connecting Africa and Europe. This project is more than infrastructure. It's a symbol of partnership, innovation, and a sustainable future. We've harnessed the Sahara's sun and wind to produce green hydrogen. Now, a monumental artery of steel, the Trans-African Green Hydrogen Pipeline, will carry this energy north. Crossing deserts and mountains, it links Africa's renewable power to Europe's energy grids, forging a permanent connection between two continents. A pipeline is more than just a long tube, it needs a heartbeat. To move gas over thousands of kilometers, you need to push it. Along the entire length of the Trans-African Green Hydrogen Pipeline, there will be a series of crucial facilities, compressor stations. These stations are the heart of the pipeline system, providing the pressure needed to keep the hydrogen flowing steadily on its long journey north. Spaced every 100 kilometers or so, these stations would take the hydrogen from the pipeline, repressurize it using powerful compressors, and send it on its way to the next station. This process is essential to overcome the friction the gas experiences as it moves along the pipe walls. What is truly remarkable about this system is how it will be powered. In a conventional natural gas pipeline, the compressors are often powered by burning some of the natural gas from the pipeline itself. This, of course, creates carbon emissions. For a green hydrogen pipeline, that would defeat the purpose. Therefore, the compressor stations for this project will be powered entirely by renewable energy. Each station could have its own dedicated solar array or be connected to the clean electricity grid. This ensures that the process of transporting the hydrogen is just as clean as the process of producing it, maintaining the green integrity of the fuel from start to finish. Transporting hydrogen, however, presents some unique technical challenges compared to natural gas. Hydrogen molecules are the smallest in the universe, making them notoriously good at escaping. They can even weaken certain types of steel over time through a process called hydrogen embrittlement. This means the pipeline cannot simply be a repurposed natural gas line. It must be built with specialized materials, using high-strength steel alloys and advanced composite materials that are resistant to hydrogen's effects. The welds, seals, and valves must all be engineered to an incredibly high standard to prevent leaks and ensure the long-term safety and integrity of the pipeline. The entire system will be monitored and controlled from a central command center using a vast network of sensors. These sensors will provide real-time data on pressure, flow rates, temperature, and gas purity at thousands of points along the route. Sophisticated software will use this data to detect any potential issues, such as a drop in pressure that might indicate a leak, allowing operators to respond instantly. This smart pipeline technology is what makes it possible to manage such a complex and vital piece of infrastructure safely and efficiently, ensuring the river of clean energy flows without interruption. The pipeline's journey continues beneath the Mediterranean Sea, a daunting feat of marine engineering. Specialized ships and remotely operated vehicles, ROVs, survey the seabed, mapping out the safest route through underwater mountains and canyons. Massive pipe-laying vessels weld and lower the pipeline in a controlled curve, ensuring it withstands deep-sea pressures and corrosive saltwater. Thick concrete coatings and seabed trenches protect the pipeline from hazards like trawlers and anchors. ROVs monitor every step, making real-time adjustments far beyond human reach. This underwater crossing is a bold link between continents, transforming a natural barrier into an energy bridge. The challenges, deep-sea pressure, shifting geology, are immense, but decades of subsea engineering make it possible. Now, this expertise is repurposed for clean energy, not fossil fuels. The Mediterranean crossing is more than engineering. It's a symbol of ambition and connection. The pipeline turns a stretch of sea into a vital artery for the energy of the future. After its epic journey, the pipeline reaches Europe's southern coast, perhaps Italy or Spain. Here, it connects to the European hydrogen backbone, a network blending new and repurposed pipelines. African hydrogen merges with Europe's own renewable supply, creating a continent-wide clean energy market. The hydrogen powers advanced plants, heavy industry, and clean transport, slashing emissions across sectors. This pipeline rewires Europe's energy map, shifting reliance from fossil fuels to sustainable sources. It diversifies supply, boosts security, and marks a strategic shift toward a greener future. The final connection is more than technical, it's a vision realized. Europe's energy future is now cleaner, more secure, and more resilient. Europe's energy has long depended on imports from volatile regions, leaving it vulnerable. The Trans-African green hydrogen pipeline changes the equation, forging a stable, clean corridor from the south. Unlike fossil fuels, this energy is inexhaustible, powered by Sahara sun and wind. The pipeline offers predictable long-term supply, insulating Europe from geopolitical shocks. For African nations, it's a path to energy independence and economic growth, not just export. Clean hydrogen powers local industries and electrifies communities, fostering true energy sovereignty. This partnership intertwines the fortunes of two continents, built on mutual benefit. Shared investment in clean energy encourages cooperation and stability. Energy security becomes a collective goal, not a zero-sum game. Together, Europe and Africa build a foundation of trust and shared prosperity. The pipeline is a catalyst for economic growth and green jobs across Africa and Europe. Building solar farms, electrolyzers, and the pipeline itself creates thousands of skilled and unskilled jobs. Permanent roles in maintenance and management anchor a new clean energy workforce. Local supply chains and manufacturing flourish, sparking innovation and enterprise. In Europe, affordable green hydrogen helps industries decarbonize and stay competitive, protecting and creating jobs. Engineering and tech firms drive new solutions for hydrogen infrastructure. Universities and colleges launch programs to train the next generation of clean energy experts. Investment in human capital ensures lasting benefits and leadership in sustainability. The pipeline transports not just hydrogen, but opportunity and knowledge. It promises a shared, prosperous future built on clean energy. The pipeline's greatest impact is environmental, directly tackling climate change. By replacing fossil fuels with green hydrogen, it slashes millions of tons of CO2 emissions. It enables deep decarbonization of hard-to-electrify sectors like steel, shipping, and heavy transport. The project is a blueprint for global clean energy cooperation, inspiring similar efforts worldwide. It proves we can harness abundant renewables and deliver clean energy across continents. The pipeline is a symbol of hope, economic growth and environmental stewardship hand in hand. It brings cleaner air, a stable climate, and a new relationship with our planet. This is more than infrastructure. It's a current of optimism for future generations. Humanity can unite to solve its greatest challenges. The Trans-African Green Hydrogen Pipeline is a promise of a sustainable, shared future. Such ambition comes with immense challenges, financial and technological. The project's cost runs into hundreds of billions, demanding unprecedented public and private investment. Securing funding requires confidence in technology, political stability, and future hydrogen markets. The financial architecture is as complex as the engineering itself. Technologically, scaling up solar, wind, and electrolyzers in harsh desert conditions is daunting. Desalination for pure water adds cost and complexity. Hydrogen's properties demand advanced materials and meticulous design for safe, reliable pipelines. Deep-sea crossings and long-distance transport push engineering to its limits. These hurdles are real, but not insurmountable. Solving them will turn a visionary project into reality, powered by the brightest minds. Building a pipeline across borders is as much a political challenge as an engineering one. Success depends on lasting cooperation, security, and environmental care. The project's impact on fragile ecosystems and water resources must be managed with sustainable practices. Overcoming these challenges is ambitious, but the reward is a sustainable future for two continents. We stand at a unique moment in history. For the first time, we have the tools to power our world without destroying it. The Trans-African Green Hydrogen Pipeline is more than steel and solar panels. It's a river of human ingenuity, connecting continents. This river promises cleaner air, a stable climate, and a future powered by the sun. The journey is long, but this project is a profound act of hope, a story just beginning to be written.